Welcome to this M1 video on constant acceleration formulae, part 1. So you may have seen these formulae before if you did like further maths or additional maths at GCSE. You may have also seen them at physics, and you might have actually seen them, on your maths course so far. But we'll go through it from the beginning. So basically, before we start with the actual formulae, we need to look at a few of the letters and generally what they mean. And these are kind of like the standard set. So we use the letter S for displacement. Okay, so distance, displacement are very similar. Displacement just has like a vector, so it has a direction, whereas distance doesn't have a direction. So S for displacement, U for initial velocity, okay, and then V is for final velocity. A is obviously the acceleration. And then finally T is, I don't know why I wrote is there. Rub that out. T is time. And the set of formulae that we're going to create over this video and the next video are generally referred to as SUVAT. Okay, so just kind of saying the letters in the order that I've given them now. Now, you need to be able to derive the formulae from a velocity time graph, which is what I will show you first, and then we'll start looking at using them. So here we have just a simple straightforward velocity time graph. Now at this point, the starting point where t is 0, our initial velocity will be u. Then if I look at the final end point here at t, that will be after a time t, and that will be my final velocity. So v, using the letters for the side here. So that's kind of how I set this up. Now, what I want to look at is two things that I can get from the velocity time graph. One is acceleration is the rate of change of velocity. So acceleration is the gradient of this line. So that can give me one formula. Okay, so if I want to find the gradient, now I'll mark this on in black, but I'm kind of looking at this horizontal value here, which would be t, and this vertical value here, which will be v minus u. And the acceleration is going to be the change in y, which is v minus u, over the change in x, which is t minus 0, or just t. And that gives me essentially my first equation. So now I can rearrange this equation. So at equals v minus u, then add the v to the other side, add the u to the other side, and I get u plus at. So v equals u plus at. So that is my first formula. Okay, now the second thing that I can get from this graph is the displacement, because that is area under the graph. So that is this area here. Now this is a trapezium, isn't it? So it's, you know, kind of on its side, if you will. You know, so looks like that, doesn't it? I'll just pop it back. So we've got now the area. So the area is going to be S. And then it's going to be A, which is going to be this distance here, which is U. Plus B, which will be this distance here, which is V. Divided by 2. Multiply the distance between them, which is T. So I get this now, S equals U plus V over 2 times T. And this is the second formula. Okay, so it's just these two formulae that we're going to deal with first. And then in the next video, I'll show you how we get the additional formulae. But let's look at how we kind of use these now in a question. So here's our first example. A particle moves in a straight line from point A to point B with constant deceleration of 2 meters per second squared. Velocity of the particle at A is 16 and the velocity of the particle at B is 4. Now, in mechanics, I'd recommend that you always sketch out what's happening. Okay, helps you visualize what's happening and generally makes the question that much easier. So we've got a particle. It's moving in this direction and it's at A. And this is now at 16 meters per second. And then it carries on moving, and then it's over here at B. And it's moving at 4 meters per second. Okay, so that's all we're told at the moment. We don't know the distance between them. So we know U is 16, we know V is 4. And we know that the acceleration is -2 because it's a deceleration. And we don't know T. And we don't know S. Now for part A, we need to find T, the time taken. So looking at these, we got U, V, A and T. So looking back at the two formulae that we have, V equals U plus AT will be the one that we want, because we've got V, we've got U, we've got A, and we want to find T. So this is the formula we will choose. And when you do these questions, you'll always choose a formulae where you've got all the information bar one letter. So V is 4, U is 16, A is -2, and T we want to find. So 2T over this side, this equals 12, so T equals 6. So the time taken from A to B is 6 seconds. Now let's have a look at part B, the distance from A to B. So distance means that we need the formula with S in it, and at the moment we only have this one. Okay, now we've got T, we can find out what S is, can't we? Because we've got U is 16, V is 4, and we know that T is 6. So 16 plus 4 is 20, 20 over 2 is 10, times 6, or 60 meters. Okay, so I found my first two answers, the time and the distance between them. Now let's take this question a little bit further. So after reaching B, the particle continues to move with the same deceleration, so still -2 acceleration. The particle is at point C 9 seconds after passing through point A. Find the velocity of the particle at C and the distance from A to C. So I've got this, and then a little bit further down, we'll assume it's here, it's going to be at point C. And this is when T equals 9 seconds. We know that this is T equals 6 and T equals 0 there. We've got to find V at this point. Okay, so that's what we're going to do now. What we can do is we can do it between A and C, or we can do it between B and C. It won't matter which one we do. I'll do it between A and C, but I'll show you the other way as well. So U equals 16. V we want to find. T equals 9. And A equals -2. So with that, we are using V equals U plus AT, because we know 3 of the letters and we're missing just the 1. So that's 16 plus -2 times 9. So that's 16 minus 18, which is -2 meters per second. Okay, so direction is important. So one thing I neglected from the start was which direction I'm taking as positive. So I'm taking this direction as positive, okay, because that's the way these are moving. So -2 means it's in the direction of A, going from C to A. So what's actually happened is, as it's gone past B, it's gone past C, and then it's come back to C at that 9 seconds. Okay, now as I said, I will quickly do it if we did it from B to C. So that would be U equals 4, V is unknown, T is 3, and A is -2. So same formula, and we've got V equals 4. I'll just put the -2 times 3 there. So that's 4 minus 6, -2 meters per second. So you can see, even when I do it from B to A, I get the same answer in the end. Okay, now let's look at part D, the distance from A to C. So we can use U is 16. We know V is -2 at that point. We know A is also -2. We know T is 9, and S is what we want to find. Okay, so we're using the formula S equals U plus V over 2 times T. Now there would be more options after the next video, as we'll have a few other formulae. But for now, let's go with this. So 16 minus 2 over 2 times 9. So that's 14 over 2, which is 7. So 7 times 9, or 63 meters. And since A to B was 60 meters, we have got C in the right place. Sometimes you might sketch things out like this and then actually find that C is here. Okay, and that's fine. You know, your sketch is just there for illustration to help you work out what's happening and what values you need to use and so on and so forth. Okay, I can't stress how important it is to get into good habits with mechanics, and good habits are drawing or sketching out, you know, what's happening in the question. Okay, so what I would always suggest is, like I've done here, sketch out what's happening. Okay, it doesn't have to be perfect, but it can really help you work out what you're going to do and answer the question. Well, that's enough for me. Now, before we look at the questions, I wanted to remind you to, you know, hit that subscribe button if you're not currently a subscriber, as I do see a lot of people aren't. Okay, it obviously helps me out, and for you, it just enables you to find my videos much easier, assuming you need them. Also, if you're a long-time viewer and you want to help out a little bit, then please consider hitting that join button. Otherwise, let's look at some questions. So here are the questions. There are 3 in total. So pause the video now for these. And then pause the video now for question 3. Okay, hopefully you've had a go at those 3. Let's have a look at the answers. So, skiers travelling in a straight line up a hill experiences constant deceleration. At the bottom of the hill, skier had a velocity of 16. After moving up the hill for 40 seconds, she comes to a rest. So again, you know, you don't have to draw a little diagram, but I will draw a little diagram. So the skier's at the bottom of the hill, and this U is 16 meters per second. And then she goes up the hill and she comes to a rest, so V is 0. This direction is positive and the time is 40 seconds. So that's what we know, okay? Or in other words, U is 16, V is 0, T is 40. Now for the first question, we need to find A. So formula that we've done so far that contains all 4 of these is going to be V equals U plus AT. And what I would suggest, guys, is that you write the formulas down before using them, because that way every time you write it down you'll slowly start to remember it, and by the time you've finished using all these formulae you will remember them all without actually having to learn them. Okay, so that's what I would always suggest. Now substitute our values in. We get this, so 40A equals minus 16. So A equals, so 16 over 40 is 2/5. So So minus 2/5 or minus 0.4 meters per second squared. Now B, the distance from the bottom of the hill to the top. So we know U is 16, V is 0, T is 40, and we want to find S. So that is the formula S equals U plus V over 2 times T. So 16 plus 0 over 2 times 40. So that's going to be 8 times 40. Again, then in my calculator, 8 times 40, and we can do this in your head, is 320 meters. Okay, and that's it. I should say that all these questions are past exam questions, maybe with little bits eliminated for them just to concentrate on the first two formulae that we're looking at today. But anyway, I digress. Let's get on to question 2. So a particle moves in a straight line from A to B with a constant acceleration of 1.5. It then moves on along the same straight line from B to C with a different acceleration. The speed of the particle at A is 1 and 43 at C. The particle takes 12 seconds to move from A to B and 10 seconds to move from B to C. So let's start off by sketching what's happening. So the particle at A, so taking this direction as positive, the particle at A has a velocity of 1 and it has an acceleration, so we tend to use kind of double arrows for the acceleration of 1.5. Now at B we don't know its velocity, and at C we know its velocity is 43. Now we know time taken, so this will be t equals 0. This will be t equals 12, and this will be t equals 22, because it's 10 seconds from B to C. Okay, so that now has got all of my information down. So the 1.5 acceleration here, the speeds of at A 1 and at C 43, 1 and 43, the 12 seconds to get from A to B, and then the 10 seconds from B to C. Okay, so I've got everything now in my diagram. So for part A, I want to look at the speed of particle at B. So that's going to be finding V. So V we don't know, but U is going to be 0, T is 12, A is 1.5. Sorry, U is not 0, U is 1. So V equals U plus AT, which is 1 plus 1.5 times 12. So that is 19 meters per second. Okay, and I could add that in to my diagram. Now, part B is to find the acceleration from B to C. So we've got U is 19. Now, if possible, don't use values that you've already worked out. So sometimes you'll be able to work out the answer with using only the values in the question rather than the values that you calculated. So if you can, you know, if we could, we wouldn't use this u equals 19. Okay, but I think in this case we're going to have to. So 19, V is 43, T is 10, and A is what we want to find. So V equals U plus AT. So 43 equals 19 plus 10A. So 10A is going to be 43 minus 19, which is 24. So A equals 2.4 meters per second squared. Now, finally, part C, the distance from A to C. So that we want to find S. We know U is 1, V is 43. Now we don't know A because we got two lots of A's. So in this case we'll use T is 22. And S equals U plus V over 2 times by T. So that's 1 plus 43 over 2 times 22. So 1 plus 43 is 44, divided by 2 is 22, times 22 is 484 meters. At least that's what I think some of you have done. But unfortunately, in this case, that would be wrong, because that only works assuming it's a constant acceleration from A to C. So in fact, that is incorrect. So I need to rub this out, and we need to look at this question again. So we need to work out the distance from A to B, and then the distance from B to C. So that is with this setup. So from A to B, we get S equals U plus V over 2 times T. Notice I always write my formulae out every time, because that's what helps me remember it. So this is 20 divided by 2, which is 10, times by 12, which is 120 meters. Okay, next I'm going to go from B to C. Just have to make a little bit more room there. So S we want to find, U is 19, V is 43, and T is 10. So S equals U plus V over 2 times T. So that is 19 plus 43 over 2 times 10. So 19 plus 43 is 62, divided by 2 is 31, times by this 10 is 310 meters. So total distance, adding them both up, is 430 meters. Okay, so you'll notice there that because it wasn't a constant acceleration across all of the parts from A to C, you couldn't just take the A value and the C value and work out the distance. Okay, because it assumes, like when you write these values down, that A is going to be constant between A and C, and which in this case it isn't. So hopefully you spotted that and did do them separately, but if you didn't, it's a good lesson to learn for the future. Now, let's have a look at question 3. So, a particle is moving with constant acceleration in a straight line. It passes through 3 points A, B and C with speeds of 20, 30 and 45 respectively. The time taken to move from A to B is T1 and from B to C is T2. Show this. So first I'll start off with a sketch. So here's my particle. This is the positive direction. So at A, this is moving at a speed of 20. At B, it's moving at a speed of 30. And at C, it's moving at a speed of 45. And it's T1 from A to B and T2 from B to C. Okay, so let's look at A to B first of all. Now, we know that U is 20, V is 30, T is T1. We don't know the distance and we don't know the acceleration. And the same is going to be said for the second part, B to C. But what we can do is we can use one of our formulae. V equals U plus AT, because it says it's moving at constant acceleration. So A is the same all the way through. So this is 30, 20 plus AT1. So AT1 is going to be 10, or A is 10 over T1. Now let's look at B to C. So that is U equals 30, V equals 45, T equals T2, A we don't know, and S we don't know. But we know that the A's are the same. Okay, we can't say that the S's are the same, but we know that the A's are the same. So using the same formulae, we got 45 for V, 30 for U, plus AT2. So that gives me AT2 is 15. So A is 15 over T2. Therefore, 10 over T1 must equal 15 over T2. And then with a bit of cross multiplication to get the T1 on the top. So T1 over T2 is equal to 10 over 15. T1 over T2 is equal to 2 over 3, then dividing both by 5. So that is part A complete. Okay, part B. So part B says that the total time from A to C is 50 seconds. So we know that T1 plus T2 equals 50 seconds. Find the distance from A to B. So we actually need T1's time. But we also know that T1 over T2 is equal to 2/3. Now we want to get rid of T2. So T2 would be equal to 3 over 2 T1. So substituting that in, so T1 plus 3 over 2 T1 equals 50. So that is 5 over 2 T1s equal 50. So 50 divided by 5 over 2 gives me that T1 equals 20 seconds. So now that I know that, I know U equals 20, V equals 30, T equals 20, and I want to find S. So S equals U plus V over 2 times T. So 20 plus 30 over 2 times 20. So that's 50 over 2, which is 25, times 20 is 500 meters. And that is the end of the video. Hopefully you enjoyed it, or at the very least got something out of it. Come back again for the next video.